You might recall graphing by transformations from an earlier math class. The most common application is to parabolas, where you will have to do some combination of vertical and horizontal shifting, as well as perhaps vertical stretching and vertical flipping. The same ideas can be applied to sine and cosine functions to get transformed versions of them. The most general forms we will be looking at involve both vertical and horizontal shifting, as well as both vertical and horizontal stretching and flipping. If you need to refresh your memory about transformations, you're encouraged to go to Desmos.com and use their slider functions to create interactive graphs that can remind you about the behaviors of graphs under transformations. Before we get into the details of that, we want to take a moment to talk about the features of the graphs that we will be focusing on. The first is the period of the function. A function is periodic if it repeats itself in regular intervals. For example, we've seen that both the sine and cosine functions are periodic with period 2 pi. As the graphs get transformed, the period might change. One way we can keep track of the period is through the fundamental period. The fundamental period is the interval on which the argument of the sine or cosine function ranges from 0 to 2 pi. As the horizontal shifting and stretching is applied, the fundamental period will shift and stretch as well. However, it will always encompass exactly one period of the functions. And by keeping track of this, we will always know what the period of the final graph will be. While there are formulas for this, we will be tracking the fundamental period through the chart of key values that we introduced in the previous video. The second feature we will focus on is the midline. The midline is just a line that cuts the sine or cosine function in half vertically. This line holds a lot of meaning in applications. It can represent the average value of the function, or it can represent an equilibrium. Regardless of the interpretation of this line, it is primarily impacted by the vertical shifts. The last feature we will focus on is the amplitude. The amplitude is a measure of how far up and down the curve's vibrations are. More precisely, the amplitude is the distance from the midline of the graph to either the maximum or the minimum. The standard sine and cosine functions have an amplitude of 1. As the graph is stretched vertically, the amplitude may increase or decrease. Over the next several videos, we will learn how to graph these transformations of sine and cosine functions. We will start by analyzing the fundamental period.